The software development process starts with requirements gathering. Requirements. Previously, it was a technical task, the main document without which not a single project began. This document was large, multi-page, with a clear structure determined by GOST, that is state industry standards, and it described, in fact, nothing more than the requirement for the system being created. But time passed, standards, notations, ways of describing requirements changed, and so gradually the terms of reference gave way to a set of artifacts consisting of two types of documents: use case diagrams and non-functional requirements. Use case diagrams make up the use case model. A precedent is the functionality of the system that allow the user to get some meaningful, tangible, and measurable result for him. Each use case corresponds to a separate service provided by the simulated system in response to a user request. That is to say, defines how the system is used. Use cases are most commonly used to specify external requirements for a system being designed, or to specify the functional behavior of an existing system. In addition, use cases implicitly describe the typical ways in which a user interacts with their system, allowing them to work correctly with the services provided by the system. Non-functional requirements. Non-functional requirements are descriptions of system properties such as features of the environment and implementation, productivity, extensibility, reliability, and etc. Often non-functional requirements are not tied to a specific use case and therefore are placed in a separate list of additional requirements for the system. Here you can see drawings with replacing the terms of reference with a set of artifacts. It's the responsibility of the systems analyst to identify use cases and actors, and he does it in order to clearly distinguish between the system and its environment, determine which actors and how exactly interact with the system, what functionality or use cases is expected from the system, and also define and describe in the domain dictionary or glossary the general concepts that are necessary for a detailed description of the system functionality or use cases. And first, where identification of precedents and actors is carried out in the following sequence: definition of actors, defining use cases, or writing a description of each use case, description of use case model as a whole. This stage includes the creation of a domain dictionary. And first step, identifying use cases and actors. Initially, the requirements are drawn up in the form of a plain text document, which is created either by the user himself or by the user and the developer together. So then the requirements are drawn up in the form of a table. Cases are placed in the left column, and actors participating in the precedent are placed in the right column. Example, the secretary posts a weekly lunch menu on the server. Employees should be able to view the menu and place an order by selecting dishes for each day of the following week. The office manager should be able to generate an invoice and pay it. The system must be written in ASP.NET. Such a simple internet application for automating lunch orders to the office. The requirement table might look like this. At the left side, president, at the right side, actor, and for president, post menu, actor for this president, secretary. Next, view the menu, actor, employer, secretary, office manager, make an order, employer, secretary, office manager, create the bill, office manager, and pay the bill, office manager. Here you can see this use case diagram, which correspond to this table. And we can see employer, which interact with the services, view the menu, and make an order. And inherited from this actor, we can see secretary and office manager. So, according to this diagram and inheritance of this diagram, secretary communicate with the services post menu, make an order, and view the menu. And office manager associate with the services, create the bill, pay the bill, and also view the menu and make an order. System boundary, context, or just system. Large rectangle containing ellipses representing use cases. The name of the simulated system is indicated at the top of the rectangle. This element of the diagram showed the boundary between what you, as an analyst, have shown as cases inside this box and what you have shown as actors outside it. Such a rectangle showed the boundaries of the simulated system itself. Inside the boundaries, there are precedents of the functionality that the system implements. Outside, actors, users, and other external entities interacting with the simulated system. Actors, this is a set of roles that a user performs in the course of interaction with some entity as system, subsystem, class. Actor can be a person, another system, a subsystem, or a class that represents something outside of the entity in question. Actors communicate with the system by exchanging messages. By clearly identifying the actors, you thereby clearly define the boundary between what is inside the system and what is outside the framework of the system. Definition of role. Actor, this is a set of roles that a user performs in the course of interacting with some entity. Role is not a specific user, but a kind of hat that a person puts on when interacting with an entity. A physical user can play the role of one or even several actors, performing their functions during interaction with a system. Conversely, the role of the same actor can be performed by several users. Here you can see use case diagram notation. Actors are often depicted as a stylized man. Despite the human appearance in this designation, one should not forget that actors are not necessarily people. Actors, as we said earlier, there can be an external system, subsystem, class, and etc. In cases where the actor has attributes that are important to show, the image of the actor as a class with the actor stereotype is used. Actors can be replaced to each other. Actors can be related to each other. The only valid relationship between actors is generalization or inheritance. This doesn't mean that in real life, an office manager and a secretary, and indeed any two employees, cannot communicate. Just when creating a precedent model, such communication doesn't fall into the area of our interest, is considered insignificant. Associations between an actor and a use case. Actors interact with the system through use cases. The same actor can be associated with several use cases, and vice versa. One use case can be associated with several different actors. Associations between an actor and a precedent are always binary. That is, they represent a one-to-one relationship. The use of multiplicity is not allowed. One actor can be associated with several use cases, but only with separate association, one for each use case. Associations can be depicted not just as lines, but as arrows. This is a directed association, and the arrow, as in other diagrams, is always directed toward the entity from which something is required, whose service is used, and etc. Use case is a description of a set of successive events, including possible variants, performed by the system that lead to the result observed by the actor. Use cases describe the services provided by the system to the actors with which it interacts. Moreover, the president never explains how the service works, but only describes what is being done. Use case diagram notation. Cases are displayed in the form of an ellipse inside the contour of which the name, description of the case is placed. The name of the president is usually much longer than the names of other elements of the model. It describes the interaction of the actor with the system, says what messages they exchange with each other. The name of the use case is rather the name of the scenario that is played during the actor's interaction with the system. Moreover, this is always a description from the point of view of the actor, a description of the services provided by the system to the user. Here you can see a simple diagram example. We can see one actor with the name passenger, with the see only one service, with the name buying a ticket, and the name of this program service cash desk. In this example, a passenger can buy a ticket for a certain type of transport at a service cash desk. Buying a ticket is the name of the scenario in which the actor passenger can interact with the system cash desk. This is not a description of the scenario, but rather the name. It tells us what the actor does in the process of interaction, but doesn't tell us exactly how. Use cases define non-overlapping scenarios of behavior. The execution of one use case cannot be interrupted by another use case. In other words, the execution of one use case cannot be interrupted by events or actions caused by the execution of another use case. Use cases act as atomic transactions that cannot be interrupted. Definition of scenario. Scenario is a specific sequence of actions that illustrates the behavior. A scenario is a narrative story about the actions performed by an actor. A story, an episode that takes place in a given time frame and a given context of interaction. Scenarios in various forms are widely used in the software development process. Despite being continuous narrative in nature, scenarios can be viewed as a sequence of actions doing a storyboard. When developing a user interface, Scenarios describe the interaction between a user or a category of users, for example, system administrator, end users, and the system. Such a scenario consists of a sequential description of combination of individual actions and tasks. For example, key strokes, clicks on controls, entering data in the corresponding fields, and etc. Scenarios can also sometimes be seen in a use case diagram. Sometimes they are depicted as a sheet of paper on which the file name is written, a rectangle with a folded lower left corner. So we can see that sometimes they are depicted as a sheet of paper on which the file name is written, a rectangle with a folded lower left corner. In this case, the specified file contains a description of this scenario. Sometimes this scenario is written as a command. Comments, notes are depicted as rectangles with a curved upper right corner and are connected to the element they explain by a dotted line. Scenario can be written in various forms: structured but informal text, formalized structured text, pseudocode, table, and activity diagram. Each scenario describes in a narrative form a completed specific interaction that has a specific goal from the user's point of view. If we consider the tabular form of the scenario presentation, then the line separating the left and right columns of the table symbolizes the border that separates the user's actions from the system's response. The tabular form emphasizes user participation, which is a very important aspect when designing a user interface. An example of a simple, non-formalized text description of a scenario. First step, the user enters a username, password, email address, and confirmation code and clicks the next button. Second step, the system asks for a verification code. Third step, the user enters the code and clicks the next button. Fourth step, the system checks that the code matches the one shown in the picture. Here you can see scenario in table view. At the left side, user actions, at the right side, system response. So we can see that user actions entering your login, password, email address, and checking the next button. And system response request to enter a verification code. Next user actions, entering the verification code and clicking the next button, and system response, checking the code for compliance with the one shown in the picture. Connection between the concept of scenario and precedent. Use cases are born from system requirements, but they talk about what the system does. How the system does it, the scenarios say. A use case can be specified by describing the flow of actions or event in textual form in a way that is understandable to an outsider not directly involved in the development of the system reader. But such a description is the scenario. Thus, scenarios specify a use case. Since scenarios are essentially stories, they are very effective means of extracting information from conversations with the customer and provide an excellent layman-friendly description of the application being created. Scenarios and indeed case diagrams complement with scenarios are an excellent means of communication between developers and the customer. And due to the simplicity of the notation, they are a means understandable to both parties. The relationship between requirements, use cases, and scenarios can be represented by such pseudo diagrams. At the left side, we can see a rectangle what to do, where we can see text system requirements and then precedent. And at the right side, we can see rectangle how to do with the text description of the use case and then some number of text scenarios. One use case defines multiple scenarios, each of which represents one of the possible variants of the flow of events defined by the use case. Scenarios are related to use cases in the same way as instances of a class. That is to say, a scenario is an instance of a use case, just as an object is an instance of a class. The system may contain, for example, several dozen use cases, each of which in turn can unfold into dozens of scenarios. As a rule, a use case describes not once a sequence of actions, but many, and it's usually not possible to express all the details of the considered use case using a single sequence of actions. For almost any precedent, one can distinguish main scenario, describing the normal sequence of action, and auxiliary, describing alternative sequences that are initiated in case of occurrence of certain conditions. Another question is such a refinement of the precedent model required? Is it justified for a given level of approximation, or can the implied alternative scenarios be omitted? Relationships between precedents. These relationships are very diverse. For example, generalization, relations, inheritance. Generalization is a relation of specialization in which objects of a specialized element child can be substituted for object of a generalized element, parent or ancestor. After we have identified and described each use case, we must look through them all for the presence of the same actions. Look, and if some actions are performed, used together by several use cases. Through the use of case generalization, we will reduce the redundancy of the model. Sometimes they talk not about generalization, but about the use of precedents. As it's supposed with inheritance, instances of generalized precedents, children retain the behavior inherent in the generalizing precedent ancestor. In other words, the presence used in use case X of a generalized use case Y tells us that an instance of use case X includes the behavior of use case Y. Generics are used to make the use case model easier to understand by reusing use case blanks to create the use cases that the customer wants. Such complete use cases are called specific use cases, often referred to as real use cases. Actors observe them when interacting with the system. Blanks of use cases created only for repeated use in other use cases are called abstract use cases. An abstract use case, like an abstract class, doesn't exist by itself, but an instance of a concrete use case exhibits the behavior described by the abstract use cases it uses. Generalization on a use case diagram. A generalization is depicted by a line with an unfilled triangular arrow at the end. Generalization is the relationship between an ancestor and a descendant, and the arrow always points to the ancestor. Arrows in UML are always directed toward the one from whom something is required, whose services are used. Generalization can be used to create different kinds of actors. Actors' descendants inherit basic characteristics from the ancestor and supplement them with their own specifics. Similarly, a child use case inherits the behavior and semantics of the parent use case and complements its behavior. Relationships between presidents. Next, relationship include. Relation include means that at some point in the base use case, the behavior of another use case is contained. The included use case doesn't exist on its own, but is merely part of the enclosing use case. The base case, as it were, borrows the behavior of those included, decomposing into simpler cases. Example of include. For example, when we buy something in a store, at the moment the cashier reads the barcode, the state of the database of goods in stock is updated. The number of cash units of the purchased goods decreases. The same action is performed in the event that the purchased product turned out to be defective, unsuitable for use, or we simply didn't like it. The state of the mentioned database is updated again, but now in the direction of increasing the number of available units of a certain product. That is, both of these actions, both purchase and return, include such an action as updating the contents of the database. Here, an inclusion is shown as a dotted line with an arrow stereotyped include. The arrow points towards the president to be included. The use of include avoids the repeated description of the same set of actions. The general behavior can simply be described as the use case included in the base. So we can see three base use case: purchase of goods, view prices, purchase return. And the two base use cases include additional use case, changing the number of items in stock. And the purchase return also include the additional use case, consumer service notice. Next, relationship between precedents, extension. The extension complements the use case with other use cases that work under certain conditions. It simply adds to the original use case the sequence of actions contained in another use case. The relationship of case extension A to case B means that an instance of case B can include under certain conditions that can be described in the extension, the behavior described in case A. We are talking about paying for some item we bought. We can pay for the goods in cash if the amount doesn't exceed $100, or pay by credit card if the amount is between 100 and 1000. If the amount exceeds 1000, we will have to take out a loan. Thus, we have expanded the understanding of the operation of payment for the purchased goods and in cases where other means of payment are used than cash. But these cases themselves arise only under strictly defined conditions when the price of commodity falls within the certain limits. So we can see this example at the slide, extension relation. We can see the main use case pays for your purchase, and it is extended with the additional use cases: pay in cash, pay by credit card, or apply for a loan. In the above example, it's not clear under what conditions a person uses each specific payment method. At the same time, when modeling using an extension, you can specify what are the conditions for the implementation of the extended behavior and the place of the extension point of the use case, at which actions from the expanding use cases are connected. In the case of an extension, it's more of a conditional branch operator when the original use case, namely the sequence of actions contained in it, arrives at the extension point. The conditions of the extension are evaluated. If the conditions are met, the use case includes the sequence of actions from the extending use case. An extension point is described in an additional section of a use case, separated from its name by a horizontal line. So we can see the main use case search, and under the line we can see extension point that is uh, uh, service condition, name of service extension point, and after presenting the ticket. In this example, the check-in of passengers of a flight includes security checks under the condition indicated in the note after the service word condition. What the person flies frequently, and the cabin is full. Pay attention to the end operator, which indicates the simultaneity of the conditions. The ticket class can be upgraded, for example, from economy to business class. Moreover, such an upgrade can occur only after the ticket is presented at the check-in counter. That is the extension point. Is described, her name is given, in an additional section of the precedent after the service phrase extension points. A use case can have as many extension points as desired. You can map a specific extension use case to a specific extension point by reading the extension conditions specified in the commands. The condition itself is written after the service word condition in curly brackets, followed by the service phrase extension point, and after it's the name of the extension point is indicated. So we can see name service word extension point, the condition after presenting the ticket, and we can see command for the condition, frequent flight and the cabin is crowded, and name extension point after presenting the ticket. The extension allows you to simulate optional behavior of the system. Would the ticket class be upgraded if the passenger didn't fly the required number of miles and the cabin was almost empty? The very effect of the expansion depends on the fulfillment of the conditions. After all, the expansion may not occur. These are simply separate sequences of actions that are performed only under certain circumstances and are included at certain points in the scenario, usually as a result of explicit interaction with the actor. So, relationships between the precedents can be generalization, include an extension. Organizing use cases by generalization, highlighting common behavior, inclusion, and different behaviors, expansion, is an important part of the process of developing a simple, balanced, and understandable set of use cases. One could even say that the use of inclusion and extension generalization is a sign of good style in case modeling. Relationship between the concepts of precedent and cooperation. We talked about cooperation earlier. Remember interaction diagrams. At a set of roles working together to provide some system behavior. We also mentioned that use cases answer the question, what does the system do? But don't say exactly how it does it. When moving to an implementation, it would be nice to know which classes or other elements of the model working together provide the desired behavior. The relationship in which there is a precedent and cooperation is a relationship of realization. Each use case is implemented by one or more collaborations. This, of course, doesn't mean that classes are rigidly distributed among cooperations. Classes that take part in a cooperation that implements a certain use case will also participate in other cooperations. So, cooperation through implementation, communicate with the precedent. Modeling with use case diagrams. The use case model is essentially a conceptual model of the system. It describes, in general terms, only the behavior or functionality of the system, but the details of the implementation are not discussed. At this stage, the implementation is not important. It's much more important to collect the requirements for the system and arrange them in a visual form that is understandable to both developers and the customer. Here, there are three ways to use precedents. First way, use cases enable analysts, users, and developers to speak the same language. Second way, use cases allow developers to understand the purpose of an element. Third way, use cases are the basis for testing an element throughout development. And first way, use cases enable analysts, users, and developers to speak the same language. Using use cases, analysts or domain experts can, based on the wishes of the customer, describe the behavior of the system from the user's point of view with such a degree of detail that developers can easily construct the internals of the system. At the same time, the annotation of use case diagrams is also so simple that even an unprepared user customer is able to understand their meaning and help clarify them. After all, pictures and even more comics, which in fact are UML diagrams, are pursued much easier than text. Next way, use cases allow developers to understand the purpose of an element. A system, subsystem, or even a class can be complex formations consisting of a large number of components and having a large number of attributes and operations. Modeling precedents allow you to better imagine the behavior of the system, to understand what elements of the model play what roles in the implementation of this behavior, which cooperations are included, and what kind of precedent or systems functionality is implemented. And third way, use cases are the basis for testing an element throughout development. The use case model describes the desired behavior of the system, its functionality from the user's point of view. By constantly comparing the actual functionality provided by the element with the available precedents, it's possible to reliably control the correctness of the implementation of the element. Here is a reliable source for regression tests. In addition, the emergence of a new use case often forces the implementation of an element to be revised to make sure that it has sufficient flexibility, mutability, and scalability. Use cases are useful for both forward and reverse engineering. Reverse engineering involves translation from a programming language into a UML diagram language. And they are used in order to find errors and to make sure the design is adequate. And the second way, when there is no documentation. First way, in order to find errors and to make sure the design is adequate. A great idea after the first translation from UML to a programming language is to do a reverse translation and compare the original and restored UML models. It's desirable that these translations are performed by different teams. This will make sure that the design of the system matches the model, no information was lost during the translation, and simply catch some bugs. This approach is called reverse semantic traceability, and it and is being developed by INTCPEI as one of the basic techniques of the INTCPEI P modeling framework methodology. Second way, where there is no documentation. Sometimes the task is to modify an existing system, the code of which is poorly documented. In this case, translating from a programming language into a UML diagram language is a great way to understand the purpose of the system and its parts, the functionality it provides, and etc. So, use case diagrams alone, as well as the scenarios they define, are not enough to create a model of system behavior. Interaction diagrams that visualize scenarios come to the rescue. So we can see additional element at the rectangle with the name how to do. At the right lower corner, we can see interaction diagram, which display the text scenarios. That is visualization of the scenario. Example of including, extending, and inheriting use cases. So we can see two main use cases: writes a press release and sends out a press release. And we can see that use case writes a press release include additional use case spell check and additional use case select recipients. The next main use case sends out a press release include the same additional use case select recipients and additional use case text encryption extend this main use case. And here we can see 5 additional use cases that are inherited from this main use case. That is sending external email, sending internal email, sending a fax, sending by paper letter, and sending via IM. Here you can see an example. Is part of the well-known fairy tale about Ryaba the hen. We can see one actor, chicken, and we can see association with the stereotype, usually with the services lays regular eggs, and the next association with the stereotype very rarely, with the service lays golden eggs, and we can see connected to these services additional command for details, the tail of the robot chicken. And conclusions for the theoretical material. The use case model allows you to describe the system and at a conceptual level. Use case diagrams are an excellent means of communication between experts, users, and developers, as well as the basis for testing the system being created. A use case is a description of a set of successive events, including possible variants, performed by the system that lead to the result observed by the actor. Actor is a set of roles that a user performs in the course of interacting with some entity. Use cases, like actors, can be generalized, that is to say, inherit and supplement the properties of their ancestor. Use cases can also enter into inclusion and extension, relationships with each other, which allows you to decompose use cases into simpler components and highlight optional behavior. Each use case is implemented by one or more collaborations. Scenarios specify use cases, and interaction diagrams visualize scenarios. Now, short technical break. Let us check who is present. Albu.
Here.
Badnar.
I'm here.
Бурлаев. Гайтукаев.
Here.
Герасимовский. Горбатова.
Here.
Грамматикати. Зазуля. Караульный.
Here.
Карватска.
Present.
Ларби.
I'm present.
Лысар. Мараренко. Сиротенко. Сивак.
Here.
Степаненко Денис.
Here.
Степаненко Сергей.
Here.
Швец.
Here.
Чевель. Димов. Чайка. Кушнир Писаренко. Давидович.
Present.
Глинка. What are non-functional requirements? How do they appear in use case diagrams? First in line is Albu.
Non-functional requirements are a description of system properties such as features of environment and implementation, productivity, accessibility, reliability, and etc., Often non-functional requirements are not tied to a specific use case and therefore are placed in a separate list of additional requirements for the system.
Okay, Bodnar.
As was stated by Vera, it's some non-functional requirements such as performance, security, usability, availability that are not it's not like not system properties. It's like system properties, not direct functions.
Okay, go to Kaya.
Yeah, as it was stated before, non-functional requirements are description of system properties such as features of the environment and implementations, productivity, extensibility, reliability, and etc.
Okay, Горбатова.
Non-functional requirements describe the system's properties such as performance, scalability, reliability, and security rather than specific functionalities.
Окей, Караульный. Ну, Карватска. Ну, Ларби.
So basically, the non-functional requirements are the description of the system or the environment in which the diagram works. So it's not included in the use cases, but are the properties of the environment itself.
Non-functional requirements are a description of system properties such as environment and implementation features, performance, extensibility, reliability, and etc. Often, non-functional requirements are not tied to a specific use case and therefore are placed in a separate list of additional system requirements. The next question, what ways of representing actors do you know? And first in line is Mararenko. Ну, окей, Сивак.
Actors can be represented as a stick figure with a name or as a rectangle with the actor name. There can also be shown in a role played by a user or an external system.
Окей, Степаненко Денис. Ну, Степаненко Сергей. Ну, Швец.
Actors can be represented in a few standard ways. For example, stick figure, named rectangle, text-only representation, and with stereotype like actor.
It can be depicted as a stylized man or as a class. Next question, what relationships can actors have with each other? And first in line is Чайка. Ну, Давидович.
Yes, generalization, inherent. This is the only valid relationship that can exist between actors. It allows one actor to inherit their properties and behavior to another actor.
Okay, Albo.
Actors cannot be related to each other. The only valid relationship between actors is generalization, or in other words, inheritance.
Okay, Bodnar.
So as it was stated
Way to
before,
cut.
the main
Please,
is
please.
inheritance.
Okay, go to Kaya.
Yeah, I can add that actors cannot be related to each other in traditional ways, and the only valid relationship between actors is generalization.
Okay. The only valid relationship between actors is generalization or inheritance. What is the meaning of the include and extension relations? And first in line is Gorbatova.
The include relation indicates that a base use case contains the behavior of another use case, which is always executed as a part of the base case.
Окей, Караульный. Карватска. Ларби.
So include means that one use case contains an actions from the other use case, and it can be used to simplify the model, not to repeat yourself. And the extension means that the relationship case B, for example, can include case A in certain conditions, and there can be some extensions to one, like in there is one more abstract case which can be extended by several different cases.
Окей, Мararenko. Окей, Сивак.
Include means that one use case always uses another use case as a part of its behavior. Extend means that one use case can optionally add behavior to another use case under certain conditions.
Okay. An include relation means that at same point in the base use case, the behavior of another use case is contained. The extension complement the use case with other use cases that work under certain conditions. It simply adds the original use case, the sequence of actions contained in another use case. What is an extension point? And first in line is Stepanenko Denis. No, Stepanenko Сергей. No, Швец.
Yes, an extension point in UML use case diagram is a specific place inside a base where additional behavior can be inserted by an extend relationship.
Окей, Чайка. Ну, Давидович.
Yes, I agree with the previous answers. So an extension point is a specific place or moment within the behavior of a base use case where additional functionality from an extending use case can be inserted.
Use case extension point that is the place where actions from extending cases are connected. Next question. List the reasons you know for using precedence. And first in line is Albu. No, Bodnar.
So precedents could be used in different relationships. They have generalization, include, and extension. So they can be used to organize use cases by those behaviors.
Gaytukayev.
Yeah, according to the lecture, there are three main ways to use precedents. First is use case enable analysts, users, and developers to speak the same language. And it also allows developers to understand the purpose of an element, and use case are the basis for testing an element throughout development.
Горбатова.
Use cases help analysts, users, and developers communicate effectively by describing system behavior from the user's perspective. They allow developers to understand system functionality and are essential for testing the system throughout its development.
Окей, Караульный. Крвацка. Ларби.
Yes, so the precedents allow us to use the generalization, include, and extension on them, which can allow us to develop a simple and balanced set of use cases. So it is mainly used to make your diagram more readable, easier, and more effective to communicate to other people, even for that who are not included in the development of the project itself.
Reasons to know for using precedents. First reason, use cases enable analysts, users, and developers to speak the same language. Second reason, use cases allow developers to understand the purpose of an element. Third, use cases are the basis for testing an element throughout development. And next question, how are use cases used in reverse engineering? And first in line is Mararenko. No, Sivak. Please, Mararenko, please answer. Okay, Sivak.
In reverse engineering, use cases are used to understand how an existing system works. They help identify system functionals and interactions between users and the system.
Okay, Stepanenko Denis. Stepanenko Сергей. Швец.
Yes, use cases yes, have an important role in reverse engineering. For example, discover system functionality, identify actors, build system requirements, also understand workflows, and also it helps support system redesign.
Okay, Давидович.
Yes, I agree with the previous answer. So in reverse engineering, use cases are used to translate a system source code back into a visual UML model. This process very important. This helps in understanding legacy systems, finding errors, verifying design adequacy, modifying existing systems.
Okay, Albo.
Use cases are used in reverse engineering in order to find errors and to make sure the design is adequate, and so when there is no documentation.
In order to find errors to make sure the design is adequate, and where there is no documentation. That's all questions for today. Thank you very much for your attention and for your answers to the questions. Your points for today. Albul 6, Bodnar 6, Gaytukayev 6, Горбатова 6, Larbi 6, Mararenko 2, Sivak 6, Швец 6, Davidovich 6. If you have no questions to me, I wish you to have a nice day and see you on next week. And now, goodbye. Have a nice day.
Have a
Thank you.
nice
Have a
day.
nice day.
Goodbye.
Thank you.
Have a nice day.